The radiator revolution. Stop heating your walls and master the thermal physics of your home. You pay to warm your living space. Yet the wall directly behind your radiator often feels hotter than the air you're breathing. That scorching surface isn't a sign the system is working hard. It's evidence that a surprising amount of your energy is vanishing straight through the structure meant to protect you. This isn't about poor habits or ancient buildings alone. It's a predictable outcome of how heat actually moves. Once you see the mechanism clearly, the fix becomes obvious, cheap, and rooted in principles that have governed every heated space since humans first controlled fire. ###1. The 10minute thermal shield, your first move. When the temperature drops and comfort is slipping, you don't need a lecture. You need results you can feel today. What you need: purpose-made radiator reflective foil or rigid reflective panels, bubble laminated or solid aluminum designed for heat reflection, not ordinary kitchen foil. High temperature resistant double-sided tape or adhesive rated for radiator use. A long, slim baton or ruler to guide the material behind the radiator. Measuring tape and sharp scissors. How to install it properly. 1. Measure the radiator's length and height. Cut the reflective sheet slightly smaller so it stays hidden from the front. 2. If brackets block the path, cut simple notches so the sheet can slide past them. 3. Apply the heat-resistant tape to the back edges of the sheet. 4. Make sure the radiator is cool. Slide the sheet down behind it with the shiny, reflective face pointing toward the radiator. 5. Use the baton to press it flat against the wall. Leave a clear air gap, roughly the width of a finger, between the foil and the radiator fins. The foil must sit on the wall, not touch the metal. Within minutes of restarting the heat, the wall behind the radiator cools noticeably while the room air reaches your target temperature more responsively. The change is physical, not psychological. ###2. The real science, 3 ways heat escapes, and why one is winning. Heat never disappears, it simply travels. Your radiator uses all 3 classic routes, but 2 of them are working against you right now. Conduction ***, heat vibrates molecules directly through solids. The brackets and the air film touching the wall conduct energy into the masonry or plaster. From there it continues outward to the colder exterior. The wall becomes a thermal bridge. Convection ***, this is the part you actually want. Air touching the hot radiator rises, circulates across the ceiling, cools, and falls again, distributing warmth. Block or misdirect this flow and you create cold spots near the floor even while the ceiling feels stuffy. Radiation ***, the hidden player. Every warm object emits infrared energy in straight lines. Like invisible light, your radiator's rear surface radiates a significant fraction of its output straight into the wall behind it. That wall absorbs the energy, warms up, and then conducts it outside. The Stefan Boltzmann law tells us radiated power scales with the 4th power of absolute temperature. A modest rise in radiator temperature therefore produces a disproportionately large increase in infrared output. Even at normal operating temperatures, the rearward radiation is substantial. Place a low emissivity surface. Polished aluminum has an emissivity around 0.03 to 0.05 between the radiator and the wall, and you create a thermal mirror. It reflects the vast majority of that infrared energy back into the room. Some of it is reabsorbed by the radiator itself, helping it stay hotter with less input from the boiler. The wall receives far less energy, so less heat conducts outward. Independent thermal modeling and field tests confirm the effect. Reflective panels can cut heat loss through the specific wall section behind the radiator by a large percentage in uninsulated or poorly insulated constructions. Overall household heating energy reductions are more modest, typically in the low single-digit percentages, yet the improvement feels immediate because the room stops fighting an invisible heat sink. ###3. Why this matters more in some homes than others. Not every living space loses heat the same way. In well-insulated, airtight modern homes with mechanical ventilation and heat recovery, the marginal gain from a reflector is smaller. In older properties with solid external walls and minimal insulation, the same intervention addresses a real, concentrated leak. This creates a quiet hierarchy of thermal comfort. Some households rely on basic, low-cost physics hacks because every saved unit of energy counts. Others invest in smart controls and zoned heating for precision. A smaller group lives in buildings so well engineered that radiators themselves are almost unnecessary. The reflective barrier sits in the practical middle. It requires no structural change, no planning permission, and no large outlay. It simply stops one specific, measurable pathway of waste. In that sense, it functions as accessible thermal intelligence, available to anyone willing to apply a little understanding of how energy actually moves. #4. Rentals, travel, and cold weather anywhere. You don't need to own the walls to improve them temporarily. A lightweight emergency space blanket, mylar, taped to the wall behind a bed or radiator works on the same principle. It weighs almost nothing in a suitcase and instantly reduces radiant heat loss from your body to the cold surface. In drafty rentals, focus first on the biggest temperature differences. Cold walls and single glazed windows radiate your body heat away even when the air feels acceptable. Covering or reflecting those surfaces changes how the room feels faster than raising the thermostat. The deeper insight: human comfort depends heavily on mean radiant temperature, the average temperature of the surfaces around you, not just air temperature. When you stop cold surfaces from stealing radiant heat from your skin, you feel warmer at the same air temperature. #5. The stoic edge: what you can actually control. Energy prices, weather systems, and the age of your building's fabric lie outside your direct influence. The emissivity of the surface behind your radiator does not. Every time you install a reflector, bleed a system, or redirect a convection current, you are practicing a quiet form of agency. You are refusing to accept that heat must be lost simply because it has always been lost that way. You are using observable reality, conduction, convection, radiation, as tools rather than mysteries. This mindset scales. Once you start seeing heat flow instead of just feeling temperature, other opportunities appear: the gap under a door, the stratification between floor and ceiling, the way furniture blocks circulation. Small, repeated applications of the same principles compound. #6. Mistakes that reverse the benefit. A few common errors turn a good idea into wasted effort or new problems. Letting the foil touch the radiator. Aluminum conducts heat extremely well. Direct contact creates a new conduction path straight into the wall. The air gap is essential. Using ordinary kitchen foil long term, it tears easily and oxidizes, raising its emissivity so it stops reflecting effectively. Purpose-made radiator foil is laminated or coated for durability. Installing over damp masonry without fixing the moisture source first. Trapped damp between foil and wall encourages mold. Address gutters, pointing, or rising damp before adding any vapor impermeable layer. Blocking the top or sides of the radiator. Convection needs a free upward path. Covering the top turns the unit into a less effective heater. #7. Beyond the foil, the full low-cost protocol. The reflector is one move in a larger system. Bleed trapped air from radiators so hot water contacts the full internal surface. Air pockets reduce both output and circulation efficiency. Position a simple shelf a few inches above the radiator. It interrupts the strong upward plume and pushes warm air horizontally into the occupied zone instead of letting it stratify uselessly at the ceiling. Manage curtains and blinds with intention. Open them during daylight to capture free solar gain. Close them at night to create a still air layer against the glass and reduce both radiative and convective loss through windows. Never let heavy fabric drape over the radiator itself. Add rugs or underlay where floors are cold. Even a thick textile layer reduces conductive loss to the subfloor and improves how warm your feet feel. Each action targets a different heat transfer route. Together they create a coherent defensive strategy rather than isolated tricks. #8. The larger truth. We are living through a period when basic energy literacy carries practical weight. Understanding that heat moves in 3 distinct ways, and that you can influence each of them, turns a passive expense into an active variable you can manage. The radiator reflector is not magic. It is applied physics made visible. By refusing to let infrared energy disappear into an exterior wall, you keep more of what you already paid for inside the space you actually use. The wall stays cooler, the room responds faster, and the system works less hard to maintain comfort. Try the installation this week. Then pay attention. Does the room reach temperature more readily? Does the wall behind the radiator feel different? Have you started noticing other places where heat is escaping without you realizing it? What other everyday surfaces in your home might be acting as silent thermal bridges? Which low-cost change would you test next? The real revolution isn't the foil. It's the moment you stop treating your home's warmth as something that simply happens or doesn't, and start treating it as something you can understand. Direct. And keep. Stay curious. Stay warm. The physics is already on your side once you stop working against it.